Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on entropy and the second law of thermodynamics. Previously, we discussed spontaneous and non-spontaneous processes. We also learned about entropy and entropy change. Entropy is the thermodynamic property of a system that is related to its degree of randomness. Entropy change is the increase or decrease in a system's disorder. In today's lesson, we will state the second law of thermodynamics. We will explain this law, as well as free energy and free energy change. The second law of thermodynamics is the connection between entropy and the spontaneity of a reaction. This law states the entropy of the universe increases in a spontaneous process and remains unchanged in an equilibrium process. Since the universe is composed of systems and their surroundings, the entropy change in the universe for any process is equal to the sum of the entropy changes in a system and its surroundings. Mathematically, the second law of thermodynamics can be expressed like this. The second law states that for a spontaneous process, the entropy change in the universe must be greater than zero. However, the law does not place any restrictions on the entropy change of a system or its surroundings. Thus, either of these can be negative, so long as the sum of the two is greater than zero. For an equilibrium process, the second law states that the entropy change in the universe must be equal to zero. Thus, the entropy change of a system and its surroundings must be equal in magnitude, as well as being opposite in sign. Students, please state the second law of thermodynamics. How is this law expressed mathematically? How is this law mathematically stated for an equilibrium process? You may begin now.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello, class. Let us answer these questions together. The second law of thermodynamics states the entropy of the universe increases in a spontaneous process and remains unchanged in an equilibrium process. Mathematically, we express the law like this. When the process is at equilibrium, it is expressed like this. If those were your answers, then you are doing great. We have learned that enthalpy and entropy are both thermodynamic concepts that are related to the spontaneity of a reaction. Let us now discuss another concept that will help us to determine whether or not a reaction is spontaneous. An American mathematician named J. Willard Gibbs was the first to introduce the concept of free energy, which is also referred to as Gibbs free energy. This state function is denoted by the letter G. Gibbs free energy is defined by this formula. Free energy is equal to enthalpy minus the absolute temperature times entropy. If a process is occurring at constant temperature, the change in free energy is shown in this expression. Gibbs free energy change provides a conclusive prediction of the spontaneity of a chemical reaction that is performed at constant temperature and pressure. This is because it includes a combination of the effects of a change in enthalpy and a change in entropy. As temperature has a positive value, the change in entropy determines the sign of the temperature multiplied by change in entropy terms. As a result, we can make several summarizations for the expression you see here. These are the criterion for spontaneous change. For a change in which the change in enthalpy is less than 0 and the change in entropy is greater than 0, the change in Gibbs free energy becomes less than 0. This creates a spontaneous process. If the change in enthalpy is greater than 0 and the change in entropy is less than 0, then the change in Gibbs free energy becomes positive. This creates a non-spontaneous process. If the change in enthalpy is greater than 0 and the change in entropy is greater as well, then the change in Gibbs free energy may or may not be negative. Only if the change in enthalpy is less than the product of temperature and change in entropy will the change in Gibbs free energy be less than 0. Let us discuss two more criteria for spontaneous change. If the change in enthalpy and the change in entropy are both less than 0, then the change in Gibbs free energy will be less than 0 if the product of temperature and change in entropy is small. This happens when the temperature has a small value. Finally, if the change in Gibbs free energy is 0, then the process is at equilibrium. In this situation, there is no driving force to push the reaction in either direction. Students, this table summarizes the criteria we have just learned. This will help to complete your next activity. Students, we have time for one more activity. Please determine whether the following reactions are spontaneous or non-spontaneous.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello again, students. I hope that you did not find that activity too difficult. Reaction A is non-spontaneous at all temperatures. Reaction B is non-spontaneous toward lower temperatures, but spontaneous at higher temperatures. Reaction C is spontaneous at all temperatures. Reaction D is spontaneous toward lower temperatures, but non-spontaneous toward higher temperatures. In today's lesson, we learned about the second law of thermodynamics. According to this law, the entropy of the universe increases in a spontaneous process and remains unchanged in an equilibrium process. We also discussed Gibbs free energy, which is used to determine the spontaneity of a reaction. We learned the criterion for spontaneous change. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.